Alright, so today I'm going to discuss with you about friction. And in general, there are two types of friction. The first one is called static friction. So this is the friction that prevents something to move. And the second one is called the kinetic friction. Basically, this is the friction force that will acting on a moving object. Now, how do we calculate the friction? So in general, the magnitude of friction is a coefficient of the friction mu times the normal. So it's very important that we know exactly how to find a normal force from an object. For example, if you have a block standing on the horizontal table, we have weight here and also a normal force that's perpendicular with the surface of the table. So in this case, the normal is just the same as weight. Now, since we have two types of friction, the static and kinetic, there are two coefficients of friction. The first one is the static coefficient of friction, and then the second one is the kinetic coefficient of friction. Normally, the static coefficient of friction is bigger than the kinetic coefficient of friction. So, for example, if a surface has a static coefficient of friction 0.3, and then now I'll give you the kinetic coefficient, for example 0.1. Now what can we have from this number? Alright, for example, in this block that is resting on a table, the mass of the block is 2 kilograms. So we can find the weight using G equals to 10. The weight is just 20 Newton. Now we can have a normal force also equals to 20 Newton. So with the static coefficient friction, we can calculate what is called the maximum static friction, right? So this is the maximum friction that we need to overcome to make the object that can move. Okay, so basically the static maximum friction is the maximum friction that we need to overcome first to make the object move. 0.3 times 20, so it's 6 Newton. Right, so for example, if you pull this object with a horizontal force F here, okay, so let me draw it in the next page. So let's say you pull this object with a horizontal force F, and you have calculated that the static maximum friction is 6 Newton. So now if you pull this object with, let's say, 1 Newton, so this is 1 Newton, and you see that this number is smaller than 6 Newton, therefore this object is not moving yet. So it's not moving. Okay, so now the next question is, what is the friction force acting on this object? Is it 6 Newton? Well, if you recall the first Newton's law, it's saying that the total force on a resting object or moving with a constant velocity is 0. That's give you the friction force here. So basically, when the object is resting or is not moving yet, the friction force here is still the same, like the force that you have to pull this object. So basically the friction force will be the same as 1. Now let's say if I pull this object with 2 Newton. So this is still smaller than this number, the maximum static friction. Therefore, the object is not moving. So the friction is also 2, and so on, until we reach 6, and this is also still not moving. The static friction is still 6. But once we give larger number, for example 6.5, so look, this force is now bigger than the maximum static friction. Therefore, this object will move. And if it's moving now, the question is, what is the friction acting on this object now? Okay, so remember we have another friction here, the kinetic friction. So this is the friction that we will use when the object is moving. So now let's calculate the kinetic friction. 0.1 times the normal, which is 20, so it's 2 Newton. Okay, so now we have friction 2 Newton, right? So the next part is to find the acceleration. So if you look at here, the force that you use to pull out this object 6.5, and the friction is 2 Newton. Therefore, the total force in the x direction, in the horizontal direction, equals to ma, and that will give you 6.5 minus 2 equals to the mass, which is 2, times the acceleration. So the acceleration here is, if you get the number correctly, 4.5 divided by 2, 2.25 meter per second square. So that's about the static and kinetic friction.